Okay, so this is the final portion of our first note section from 1.1. What we're going to look at here is a definition. So when we were making our prediction on the next three terms of the sequence, what we were actually doing was we were making a conjecture, which is a conclusion that you reach based on inductive reasoning. In other words, it's an educated guess. And you've probably heard about this through science, perhaps, or other subjects even maybe. Okay, so here's an example of a conjecture. Mrs. Lattice gives us a conjecture. By the end of the week, you will be expecting homework on a daily basis. Now, she's making that conjecture because she notices that we have homework assigned every single day. So what should you expect? Well, you should probably be expecting homework every single day. That's the pattern. Okay, so conjectures could be true or false. Every prediction that you make isn't always correct. How do you know whether a conjecture is true or false? Well, if you can find one example that does not follow that conjecture and that makes the conjecture false, that would be called a counterexample. You only need one counterexample to prove that the conjecture is false. We're going to use an abbreviation for counterexample. Instead of writing out the big long word, we're going to use the letters CEX for counterexample. Let's look at an easy example where you would use this counterexample. Here's a conjecture. All dogs have spots. Is that true or false? I think we all know that that's false. Now, how do you prove that it's false? You need a counter example. So this is what you would write down on your paper. Write down CEX. This is your counter example. And then you're just going to give a type of dog that doesn't have spots. Like maybe a pit bull or a lab of some sort. Now, there's lots of different types of dogs that don't have spots. All you need to do is list one. And your one doesn't have to be the same as the one as somebody else lists. There's lots of different possibilities, potentially. You just need to give us one. Now, again, what did this have to do with math? Well, not a lot of dogs come up in math class, so that part of it has nothing to do with math, but the conjecture portion does. Here's a conjecture that deals with mathematics. The product of two positive numbers is always greater than either number. This might seem a little trickier, a little tougher, mainly because there's words. Some of the words you might not know the meanings of, so we should probably talk about that first. Okay, so if you're following along with your notes, that word product, it means something. Product means the answer when you multiply. Macy, yes. I'm recording something. It's okay. So we're going to multiply two positive numbers, is what it says. Positive means it's got to be greater than 0. So we can't use 0 and we can't use negative numbers. Now, when we multiply these two numbers together, is it always going to be greater than either number? That's what we got to figure out. So let's just go with an easy example to start with. Let's multiply, because it says product, we're going to multiply 2 times 5. I'm just picking two numbers that are positive. Now, when you multiply 2 and 5, you get 10. 10 is your product. Is 10 bigger than 5? Yes. Is 10 bigger than 2? Yes. So it looks like this conjecture works. But we need to work this out with a bunch of different types of numbers. So for example, let's not just use 2 and 5. Let's maybe use some bigger numbers. Maybe I'll use 10 and I'll use 17. 10 times 17. That's going to give me a product of 170. Is 170 bigger than 10? Is it bigger than 17? Yes. It looks like the conjecture works. Again, you can mix it up and try different numbers again. Maybe we can try decimals. How about I take 3.5 times 2? They're both positive, but I'm trying a different type of number to see if I can prove that this conjecture is false. 3.5 times 2 equals 7. Is 7 bigger than 2? Yes. Is 7 bigger than 3.5? Yes. Again, it looks like the conjecture works. But it doesn't. Hopefully, you've caught on to a way you can multiply two numbers and not get a product that's greater than either number by now. What if you multiplied 8 with 1? 8 times 1. They're both positive. 8 times 1 is 8. 8's bigger than 1. Is 8 bigger than 8? It's not. So that is your counterexample. If you can multiply a number with 1, you're going to get the counterexample to this conjecture. Okay, so that's the type of thinking that we're going to do in the tougher problems in this section. Okay, if you have any questions, as always, just don't be afraid to reach out. Thanks. Have a good day.